Okay, today we're going to be doing product of array except self on Leetcode. So the question is, given an integer array nums, return the array answer such that answer at I is equal to the product of all elements of nums except the ith num itself. And it says the product of any prefix or suffix of nums is guaranteed to fit 32-bit integer. You must write an algorithm which runs in OFN time without using the division operator. So we cannot divide the number at index I. And it's asking if it's possible, can we write the code such that it takes only O of 1 space complexity? The output array does not count as extra space for the space complexity. Okay. So this basically means that the output or the return value here, ignoring that return value, can provide a solution which otherwise returns in O of 1 space complexity. So let's make room to analyze the examples. So if we have this input, we want to generate this output. Okay, so, and we can only use one array which has to be the output. So one thing we could do is see if it's possible to use, because we cannot use the division operator, so we have to see if it's possible to store some sort of intermediate data structure that allows us to compute multiples, excluding the ith multiple itself, easily. So there's only two things you can do is with a list that would optimize multiplication. That would be to have either a prefix sum or a suffix sum. And if you don't know what a prefix sum is, it's basically, so a prefix sum would be just 1, and then 1 times 2, which is 2, and then 1 times 2 times 3, which is 6, and then 1 times 2 times 3 times 4, which is 24. And then the suffix sum would just be the opposite. So it would be 4 and then 12 and then 24 and 24. So if we have these two intermediate arrays, can we easily generate the output? And we can see that if we have these two arrays, all we would need to do is multiply numbers that are outside the ith index, one from the prefix sum, which is this, and one from the suffix sum. So as an example, if I is equal to 1, so the second index here, we would need to multiply 1 with 12, and that's how we would get 12. And you could do this with the remaining. So if I was 2, which would be so we would be ignoring 3. We can take the previous index, which would be the first index in the prefix sum, so that's 2. And we can take the next index in the suffix sum, so that's 4. And then we get 8, which would then again go into the second I equals 2 location of the result. So that's a general idea. Let's see if we can do this in O of 1 space, ignoring the returning data structure. So we have result, and we can have it store, initially we can just have it store ones. Let's have n as a length of nums, and we can say result initially is just ones. Now we need to either pre-create a prefix sum or a suffix sum. So I think it would be easier to create the suffix sum, but you could also write the algorithm using the prefix sum, I believe. So let's return result, and let's create the suffix sum. So for the suffix sum, we would need to loop through nums. So for idx, num in enumerate. Since it's a suffix sum, we would have to enumerate to the reverse of nums. Reversed of nums. And now we need to compute the right index. So right index is equal to n minus index minus 1. And what we would need to do for a result is essentially just do result of right idx is equal to num times result of right idx plus 1. So this should compute the suffix sum for us, but here we have an edge case because adding a 1 here would take the index out of range for the size of result that we have. And one easy fix for that would be just to have result be n plus 1 in size to begin with. So that would be the suffix sum. And now we need to compute the final result. And while we compute the final result, we can store it. We can just overwrite the result array we already have to keep the O of 1 space. And as we go through, as we loop through it, we can compute the prefix sum and create the result that way. So if that doesn't make any sense, let's write the code here. So I can have a prefix here, which is initially set to 1. We can loop through for I in range n. So we're looping through result. We can say result of I is equal to prefix times result of I plus 1, which is suffix multiple. So prefix multiple times a suffix multiple, and then we would need to do prefix is multiplied with the current current number that we just passed. And so we continue to compute the prefix sum. The suffix sum is already computed and is being overwritten by the result that we compute. So the result is just prefix times the suffix, and then we can return it. I think this should work. Let's try it. Okay, all right. So we can see that we added an extra element at the end as padding to make the computation here simpler. And so when we return, we just want to ensure we don't return that value. So that should do it. Okay, let's submit. Cool. Let's just double check the space-time complexity. So the time complexity would be we're looping through nums separately in a for loop twice. So that's just O of an average time complexity. And the space complexity, again ignoring the result which we're returning, would be O of 1 since we don't have any additional data structures. cool. That should be it.